Okay, so I liked question 2, partially because it was our first, I think, where we had something like this, maybe. Most of the time, I feel like when we were solving things for our looking or deciding whether or not sets of vectors formed a basis, in our previous 2 versions of this quiz, they always failed both properties. And so they weren't very exciting. This one fails only one of the 2 properties necessary to form a basis. And it's an obvious one. We see right away 2 things. We only have 3 vectors, which means there's no way we can span, right? Our vectors, there's no way we're going to get the pivots for each column. We also see that we don't have a square matrix. We have a matrix that's 4 by 3. Both of these things alone are telling me that I am not going to be able to have a basis. So I could just stop right here and say, there's no way that this could span. And that's all I really need. I could say no, the set of vectors does not form a basis because they do not span R4. Number of columns / vectors. Right, I want is smaller. Right, I could say that. That's one way to talk about it. Or I could do the more traditional way we've been talking about linear. We've been talking about span, which is the number of pivots doesn't equal the number of rows. Okay. But I really like this one because most students, you guys were awesome. In fact, I forgave a little bit of poor language in other places, because if you said, but surprisingly, right, but they are linearly independent because we do have a pivot in each column. So they do meet one of the 2 criteria. They're linearly independent, but we don't meet the second criteria. They don't span our R4. So that was the answer to 2. If you talk to me about both of the 2 properties, I was just over the moon, though it was not necessary because we know in order to disprove something, we just need to show one of the things that we need fails, and here we could show that we failed to span. So if you didn't talk about linear independence, you're still completely okay.